Let's do that. Okay. So, we're going to move on to section 1.3. So remember what we're doing here. We are kind of introducing the topics basically in the order that they would be encountered in primary school. Okay, so first bit of math you do is counting. And then you learn to write your numbers. Okay, we have to write them using the place value system. So that's going to be a thing that students need to start learning, and that they start to learn that pretty naturally. Okay, and kids like counting. Okay, one of the things, if you meet a 5-year-old, they sometimes will just come up to you and tell you how high they can count. Okay, and they'll ask you to listen to them counting. Okay, so they like to do it. They don't just necessarily have to count by ones. They can do skip counting too. They can like count by tens. Okay, and that's an important stepping stone to learning the place value system. In fact, sometimes they'll just kind of do that by accident. They'll go 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, right? So that's an important thing to the place value system. So you got your counting. And we did talk about some different models that we could use to help students picture numbers and understand them. What were the two models that we talked about? Set model and the measurement model. What was the measurement model again? Number line. Okay, we would kind of draw it on a number line and put marks on the line for each of the numbers. So what's the next thing? You learn your counting, you learn how to write numbers. What's the next thing?
Addition.
Addition. Okay, you start to learn the operations you can do with numbers. And addition is the simplest operation. Okay, so the key ideas for this section, whoop, are knowing the any order property of addition. And knowing some mental math, okay? So basically, when this section is over, those are the things that I need you to understand here. Okay. So when you introduce a topic, explain with models, okay, use concrete stuff, and we know we have these two models to illustrate things, okay, we have the set model, okay, which is great. Okay. Because we can kind of show that when we're adding things, we're combining. Okay, so what am I illustrating here? What operation am I illustrating with that picture?
Addition.
Right, addition. And what's the addition problem?
3 plus 5 equals 8.
Okay, 3 plus 5 equals 8. Okay, so we got the one set indicating 3, the other set indicating 5, and we combine them into one big set with 8 objects. So that's good to introduce it. The only kind of weakness is with this model, students don't actually add. They tend to count rather than add. Okay, so they see these two pictures and they go 1, 2, 3, 4, 5, 6, 7, 8. I didn't really add, I just counted. Okay, What we want to do is start building up so that they don't go from the beginning every single time. And that's where the measurement model comes in handy. Where we're counting up. Okay, so if I wanted to illustrate 3 plus 5 equals 8 on the measurement model, I would start at 3 and count up. 3, that's 1, 2, 3, 4, and 5. Okay, maybe I'll just do a jump there. Okay, 5. So 3, count up 5, you get to 8. Okay, so a measurement model starts to get them away from that counting. Now, there is still some counting. Sometimes students will count it off like this. So 4, 5, 6, 7, 8, right? But at least they're starting at 3 and not going right from the beginning. Okay, now, eventually, we want to get them to the point where they don't have to use a model at all, and they just know that 3 plus 5 is 8. Okay, we want them to eventually get to memorizing their addition facts, because that's going to be the basis of their later work. Okay. So, on page 14 of your book, if you've got it, you can open up with me and check this out. On page 14, they have this picture here, kind of indicating some grade levels and what's getting done at those grade levels. Okay, so these operations are actually introduced in kindergarten. Okay, you could do set model addition with a kindergarten. They don't need to know their addition facts. Remember, we talked about they just need to do counting, and they like doing counting, so they can do those kinds of problems if we give them the models. Okay, they could probably even do this. Okay, so we introduce them in kindergarten. We have development and practice in first grade, and then that little bit at the end. What's that word?
Algorithm.
Algorithm. Okay, the algorithm is the kind of standard pencil and paper algorithm that we have for adding numbers that involves carrying and stuff like that. Okay, so that gets introduced a little bit later in the second grade. Okay, the algorithm for addition with the pencil and paper stuff. And we'll talk about that as we go through the course. Okay. So addition applies to two numbers, right? I can't say add 3. Add 3 to what? I can say add 3 and 5. I got to give you two numbers. Okay, and in fact it applies to exactly two numbers. Well, could I give you more? Could I say add 3 and 5 and 7? Sure. And how would you do that? What do you do if I gave you 3 numbers to add?
Yeah, I'll be better.
Okay, how do I start?
Start with 2, and then whatever you get from that, add the third.
Right, start with the first 2, add those, and then whatever you get as a result, now you add the third to that result. Okay, so you're still taking them 2 at a time, right? It's not a new operation where I can now add 3 numbers, it's just I add the first 2, and then whatever I get, I take that and combine it with the third one, okay? So, a couple of notes here. Adding applies to 2 numbers. I have to give you 2 numbers. Question is, well, what if you have more than 2? Well, we already know what to do. Let's stick with that example that we had right here. 3 plus 5 plus 7. Okay? So, remind me again, how would I do this?
3 plus 5
Okay, 3 plus 5, which gives me 8, of course. And then what?
plus 7.
Plus 7, and then I do 8 plus 7 and get 15. Okay? So I added these two, and I added these two. Okay. Now, do I have to do it left to right? Okay, no, I could have switched it up if I wanted to. Okay, so what we really did was we did this problem. 3 plus 5 plus 7, okay? What do those parentheses indicate?
First.
Right, that's what we did first, okay? So we did the 3 plus 5 first, and then we did the 7. That's what we did right here, okay? So that raises sort of a natural question. What if you switched it up? You said we could add two numbers. What if I added the 2 on the right first, and then threw in the middle? Do I get the same thing? Okay, now in this case, yes. And addition is a very special operation in that sense. Not every operation allows us to just switch the order willy-nilly. So addition is very nice like that. Okay, well, 3 plus 5 plus 7 would be 3 plus 12, which would be 15. Okay, so we can get the order, or sorry, we can get the same answer no matter what two that we group together first. Okay, that actually has a special name. That's called the associative property. And the associative property in symbols says this. Okay? So that's part of the any order property of addition. But that's not the only part of the any order property. Okay? If I were to say, okay, any order, and I just gave you this problem, well, 3 plus 5 is 8. If I do 5 plus 3, I should also get 8. The set model makes that pretty clear, right? Okay, you don't have to start with 3 and then add the 5 to get 8. You could also start with the 5, 6, 7, 8. Okay, either way, you end up with 8. Okay, so that's called the commutative property of addition. And these two things together are what your author calls the any order property. Okay? So you can group them however you like. You can also switch them however you like. Okay. Okay, now, the any order property gives us a ton of flexibility for adding. So we can do additions in the easiest way possible. We don't have to start from the left and then add the next one and then take the result from that and go to the next one. Okay? We can be smart about it. So if you have an addition problem, I highly recommend you look at the whole thing. Okay? Take a kind of a long view. Take in the whole thing. Notice this plus this Okay, what is 9 plus 11? That's 20, okay? So if we do this and this, we get 20. What do you want to throw in next? It doesn't really matter, but throw in the 10. 20 plus 10 is 30. And now what?
Plus 8.
Right, throw the 8 in, okay? So, if you remember from last class, I think I mentioned something called tens combinations, okay? This is kind of important for recognizing when you're doing addition problems. If you got a 9, look for something in here that has a 1. Look for a 1 in there somewhere. We can see there's a 1 here. 1 plus 9 gives us a 10. So, and of course, it's 11, so we got 20, okay? So the important thing is we got a multiple of 10. Now, it's much easier to do arithmetic with multiples of 10 than it is with just random numbers, okay? So we combine those, we get a 20, combine that with a 10, and you get a 30. Okay, so I'm looking at this. Okay, now, I know I wrote a lot more than we really needed to write there. I mean, heck, we got the answer 38 without writing anything down, okay? I just wanted to illustrate the line of thinking that we were doing to get this problem done, okay? So, let me try this. Let me try some other kinds of problems where it benefits us to go a little bit further down the line. Okay, so let's try something like this. Let's try 34 plus 17 plus 6. Okay, now, I'm looking at this and I could just plow ahead. I could do 34 plus 17 and figure that out, and then when I get the answer to that, I can add 6. There is a way of doing it that makes this problem much easier. So what should I do first?
34 plus 6.
Right, 34 plus 6. Now why does that make the problem easier?
4 plus 6 makes it 10.
Right, that makes a 10. Okay, that's one of the tens combinations. You're seeing a 4 here. Doing the 4 plus the 7, that makes an 11. Now there's going to be carry. Okay, if I have to do 34 plus 17, I have to do carry. Remember, look at the whole thing. Spot tens combinations, 34 and 6. Those are the ones you want to do. 40 plus 17. And what's 40 plus 17?
57.
57, okay? So, looking at those tens combinations, making use of the any order property lets us do these addition problems much easier. The thing we're trying to avoid doing is carrying, okay? Now, sometimes you just have to do it, okay? Sometimes you got a problem where you don't have a tens combination and you have to use the standard pencil and paper algorithm, okay? But there's plenty of stuff that you can do mentally, okay? So, one of the things that you need to be able to do as a teacher is, let's say you got a class and, you know, it's not a pandemic or anything like that, and they're all working at their desks. You give them a worksheet, okay? You give them a set of addition problems to work on, okay? You don't want to be carrying around the answer sheet and looking at their work and looking at the answer sheet, okay? You got to be able to do a little spot check. You need to go around the room and see if they're getting the right answer, which means you basically need to be able to do those problems in your head. Remember, I'm not asking you to memorize the answers to the entire worksheet. That'd be almost impossible, okay? But you need to be able to do those pretty quickly. The way to do those quickly, learn to spot the tens combinations, okay? Don't just plow ahead in the order that you're given the numbers. You got the any order property. You can switch it up and do it in whatever way is easiest. Okay. So, let's try some more sophisticated uses of the any order property. I want to try this. 38 plus 32. Okay. So, here's what I'm thinking. Okay, if I see this problem, I won't even write this down, I'll think it, okay? So as we go through, we're gonna wanna start to internalize that. At the beginning, we're gonna write down what we're doing, okay? Okay, expanded notation, right, that's 38, 30 and 8. This is 32, 30 and 2. How does thinking about it like this help me do the problem faster?
Combine 8 and 2 to make 10.
Right, make a 10 right there. 8 and 2 make a 10. So, typically I wouldn't write them out in expanded notation, okay? I might just do something like that. Okay, what do you think that little note means? I got an arrow going over there with a 2.
Carry the 2.
Right, we're moving that 2 over to here. This has a 30 and it has 8 more. If I move 2 over, right now over there I have 40. And over here I still have the 30, right? Because I took 2 away and put it over there. And now what's the answer to this problem? 7, okay? So finding that tens combination, now like I said, as we get practice, that's something we want to start to do mentally. Notice there's an 8, there's a 2, move that 2 over. Get a multiple of 10. And then do the work with multiples of 10. Let me see here. How about this one? Try it in your seats. Try to use this idea up here to do the problem mentally. But I want you to write that, indicate like with an arrow or something like that. Indicate a step. Excuse me. Okay, good. Yeah. Okay, great. Yeah. Okay, so we're looking at this problem. We see we got a 9, we got a 1. Thinking our tens combinations, we see that 9. We're automatically thinking tens combinations. We want a 1 somewhere, we can find it right there. We move it over. That's now a 50. That's now a 20. Maybe I'll write down that intermediate step 2. And once again a 70. Okay, let me do a couple more here. Okay, how about this? What if I had 228 plus 96? Okay, now this one's going to be a little more tricky. Naturally, it's one of those things where there's really no wrong way to do it as long as you get the correct sum, okay? However, there's a really easy way to do it. There's a best way to do it. Okay, you might say, all right, I see an 8. So my tens combinations would be a 2. Now, you might say, well, you don't have a 2. Well, actually you do. You have 96. So you certainly have a 2. So you could bring a 2 over. Now, that's not great. It's okay. But it's not great. Because remember, the whole idea is to avoid having to do carry. Okay, so let me write down something just so my idea is clear. But I don't want you to write this down, because it's not the best way to do the problem. So if I see that 8, and I say, okay, I want to bring over a 2. So that's 230 plus 94. Okay, 230 plus 94. Now I still have to do carry, right? Because I have 23 plus 90. Okay, so that's maybe not great. Is there any other way to do this so that I don't have to do carry?
Take 4 from 228.
Okay, right. It's best if this is 96, you're adding 96. Kind of hard because of the 9. Okay, the 6, of course, doesn't really help either, but the 9 is also making things hard. So is there any way we could make this a one-digit thing? In other words, with zeros in other places? And the answer is, of course, yes, we can. We would bring 4 over this way. So it becomes 224 plus 100, 324. Okay? So one of the things I want to kind of impress upon you as we go through this class is a lot of people view math as very mechanical. In other words, you have the instructions, you start at step A, and you just do the instructions. Okay, now that's the way computers do math, and they're very fast at it and very accurate. Okay, but that's not the way humans think, and that's not the way humans work best. And math isn't really about just kind of plugging and chugging. I mean, sometimes you got to do it, but if you can avoid doing that, you should avoid it. And here, there's a very easy way to avoid it. Okay, just realizing we can do this addition in any order. Now here, this is a little bit more involved than the original problems that we had. Here, we weren't breaking up the numbers. Right, we had 34, we noticed, okay, 34 plus 6 gives us the 40. Do that and then add the 17. The idea we're emphasizing here is that, well, you can always do that, right? Because, yeah, you have a 1. This is 20 plus 1. We're just breaking up that number into expanded form. And you can break it up in any way you want. This is 224 plus 4. Bring the 4 over here. And the whole point was get 100 and make it a one-digit problem. Okay? So math becomes very easy if we work with multiples of 10, multiples of 100, things like that. And that's because we have a place value system. Okay, the place value system makes multiples of 10 easy to work with, multiples of 100 easy to work with. Okay, let's see. I want to try 2 more. So, okay, I want you to try these in your seats. Write down one step to indicate what your thinking is, and then try to get to the answer. So that first one is 793 plus 428, and the next one is, the first one is 36 plus 35, and the next one is 793 plus 428. Let's see. Huh, am I the only lefty? Oh, is there a lefty over there? Okay, one lefty. Oh, 2 lefties. Okay. Yeah, good. Let's see. Yeah, that looks good. Okay, great. Right, that's the way you want to do it. Yeah, that's right. Okay, remember, dealing with stuff that has lots of zeros is the best way to do this. Yeah, that's the best way to go. Okay. So let's start with this one first. I saw people do it a couple different ways, so you have quite a bit of flexibility on this one. You could take, if I wanted to go this way, what would I do if I wanted to do that?
4.
I would take 4 to make a 40. If I wanted to go this way, what would I do? I would take 5, make that a 40. Okay? And so, either way, we get to 71, right? Okay, now here is a bit less flexible, okay? There's a good way to do it, and there's a way that will lead to more work than we really want to do. Okay, I could do that. I could do a 2, right? Now, what's the problem? Right, you'd have 791 plus 430. You still have to carry if you do it that way. So remember, what you want is you want the maximum number of zeros when you do this, okay? If I bring over a 2, that gives me a 0 here, so that does make the problem a little easier. But there's a way to do it that'll make it easier still. So what should I do? Okay, and what would I take over there? 7, okay? So what happens if I bring over a 7?
Makes it 800.
That makes it an even 100, okay, an even 800. 800 plus 428, which gives me 1228, okay? Well,
Took 7.
sorry. One more time? Oh, yeah, 21, yeah. I forgot to take away the 7. I added it over here, but then I kept that as an 8. Okay, so we want 1221, okay? So that's the thing with these tens combinations. We can use them to help make our computations a lot easier. So don't try to be like a computer. Don't try to just plow through it. Look at the whole problem. See if there are any pieces that fit together naturally. And if they do, combine them. Okay, what are we looking for again when we make these choices? Tens, right? We're looking for zeros in various place values. That takes a 3-digit addition problem. We turn that into a 1-digit addition problem. All you have to do is 8 plus 4. Okay? Rather than, this would involve carry in all the decimal places, right? If you add the 1s, 11, carry the 1. 1 plus 9 plus 2 is 12, carry the 1 again. Okay, so doing it standard pencil and paper algorithm, yes, you will get the answer. But there's a very quick way to see it using the any order property. Okay, so I want you to read through section 1.3 in elementary math for teachers. Goes from page 14 to page 18. And let me see. On page 18, I would like you to do 1 through 5